Hey, hello everyone, and welcome to the fourth lecture of my classical mechanics course. And I'm sorry for not uploading, um, a lot of videos recently. This is like, I don't know, I'll upload this video like 3 months. I don't know how many days it has been since I've uploaded the last video. But okay, let us start today. And we're gonna start with a very important topic, which is acceleration. Can you guys see that? I'm not sure if you guys can see that. You know what? This will surely be visible. Yep, that is. Okay, acceleration. So let us first understand what acceleration means. To accelerate means to change velocity. So to accelerate means to change velocity. So acceleration is the change of velocity with respect to time. So acceleration, change in velocity over a certain period of time. For example, let my velocity, like I was at a velocity of 2 meters per second, and then I switched up to the velocity of 5 meters per second in 3 seconds. So suppose, let me write this. Initially, or let me denote my initial velocity as VI. My initial velocity was 2 meters per second. And then when I switched up my velocity turned to 5 meters per second. And this process of changing my velocity from 2 to 5 took me a good 3 seconds. So acceleration here should be defined as A is equal to Vf minus Vi upon delta t. I've talked before that delta means change in. So the change in time, since change in time went from when I switched my velocity is 3 seconds. So Vf minus Vi is 5 minus 2 and delta t is 3. This will amount to 1 meter per second, and as you see that there's velocity and then there's time. So velocity's unit is meter per second and time's unit is second. I don't know if you guys can see that because of the reflection. Well, you know what? Alright, here. Yep, it should be visible here. So velocity's unit is meter per second and time's unit is second. And if I divide meter per second by second, I get meter per second squared, because I have 2 seconds in division. So the unit of acceleration would be meter per second squared. Yeah. So what does this mean? What does acceleration is equal to 1 meter per second squared mean? It means that I'm changing my velocity by 1 meter per second every second. So my velocity changes by 1 every second. That's what acceleration denotes. So let me change my marker. Oh my god, this marker is not working. New marker. Let's go. So acceleration is equal to delta V upon delta t. Changing velocity upon changing time. And this is the average acceleration. That looks like an N. Okay. That's how you calculate the average acceleration. So if you recall, velocity was a vector quantity. It means that velocity depends not only on magnitude but also the direction. So suppose I was here at this point, my velocity was 1 meters per second. Then I went somewhere else, maybe this point, and over here my velocity was, say, 5 meters per second. And the time taken by me to reach from point A to point B was 2 seconds. So acceleration here would be A is equal to delta V upon delta T. Delta V means the change in velocity. Change in velocity is 5 minus 1, which is 4, and delta T is 2. So 2 meters per second squared. Always remember, the change is always calculated. Delta stands for the final state minus the initial state. It's always the final minus the initial. It's never initial minus final. So that means that, let's take one more example. At a point here, point A, and my velocity is 6 meters per second. And then I travel another point B, and velocity here is 2 meters per second. And traveling took me 2 seconds. So the acceleration in this case is delta V upon delta T. Now, delta V is final velocity minus the initial velocity. The final velocity is 2 meters per second. And the initial, at the starting, it was 6. 2 minus 6 upon delta T is 2. This will amount to minus 2 meters per second. Can you guys see that? Now you guys can. Okay. So that is my acceleration in this case. In this case, the acceleration is negative. So negative acceleration, let me write it as, when change in velocity is positive, then it is called acceleration. And when change in velocity is negative, it is called retardation. Yep. So in the previous example, my acceleration came out to be minus 2. So the change in velocity is negative because it was 2 minus 6 is equal to minus 4. The change in velocity is negative. So the acceleration was minus 2 meters per second square, or so the acceleration was minus 2 meters per second square, or the retardation was 2 meters per second squared. Retardation is just the negative of acceleration. Retardation is slowing down and acceleration is speeding up. Thanks for watching.